Hi guys, my name is Rashawn and today we're going to be analyzing a problem on forces, using free body diagrams of those forces to find the magnitude of the normal forces, the frictional forces, and the acceleration of the various components of the system. We're going to be doing problem 1998 M3. The problem states that block 1 of mass M1 is placed on block 2 of mass M2, which is then placed on a table. A string connecting block 2 to a hanging mass M passes over a pulley attached to one end of the table, as shown above in this diagram. The mass and friction of the pulley are negligible. The coefficients of friction between blocks 1 and 2 and between block 2 and the tabletop are non-zero and are given in the following table. Express your answers in terms of the masses, coefficients of friction, and g, the acceleration due to gravity. For the first part of the question, we are asked to find the normal force exerted on block 1 by block 2. Looking at our free body diagram, it states that Fg is equal to m1g. Since m1 is not moving, the sum of the forces acting upon it have to equal 0. In other words, F net has to equal 0. So m1g minus Fn1 is equal to 0. Thus, Fn1 is equal to m1g. For the second part of the question, we were asked to find the friction force F1 exerted on block 1 by block 2. We have found that Fn1 is equal to m1g, and that Ff is always less than or equal to mu Fn. Since the friction force acts in the x direction, the friction force is less than or equal to mu Fn cos theta, where theta is 90 degrees, because the angle created between the normal force and the x component is 90 degrees. Now, for the next part of the question, we are asked to find the tension force exerted on block 2 by the string. We know that the string provides the same tension force on block M and M2. So now we're going to use this free body diagram to find the tension force. So thus, we know that F net is equal to 0, which is equal to Ft minus mg, minus large mg. Thus, force of tension must equal to mg, large mg. Now, to find the normal force exerted on block 2 by the tabletop, we have to realize that the gravity force acting upon it is not just m2g. Since the m1 block is on top of block m2, the gravity force acting upon m1 must act upon m2 also. Therefore, since F net is equal to 0, as m2 is stationary, Fg minus n2 is equal to 0. So as mentioned before, Fg2 is equal to m1 plus m2 times g. So thus, Fn2 must equal to m1 plus m2 times g also. The next part of this question asks to find the friction force F2 on block 2 by the tabletop. To find this, we must look at the FBD for M2. We notice that the forces in the x and y components all add up to 0. To find the friction force, we must look at the forces in the x components and find that F net in the x direction is equal to 0. So therefore, Ft minus friction force is equal to 0. Since the tension force is the same on block M as it is on M2, the tension force is mg minus Ff is equal to 0. Thus, Ff is equal to mg. Part B of this question asks to find the largest value of m for which the blocks can remain at rest. The maximum friction force on the blocks on the table is F2 max is equal to mu S2 times N2. F2 max is equal to mu S2 times Fn2 is equal to, since we defined Fn2 as m1 plus n2 times g in the problem earlier, it's equal to mu S2 times m1 plus m2 times g. This is balanced by the tension of the hanging mass mg. So we're going to put them equal to each other since the acceleration is 0. So then the sum of the forces in the x direction is 0. mg is equal to mu S2 times m1 plus m2 times g. Now we divide both sides by g, and we get that m is equal to mu S2 times m1 plus m2. Now, for part C, we are given the situation that m is large enough that the hanging block descends when the blocks are released, and we are supposed to assume that blocks 1 and 2 are moving as a unit. We are asked to find the magnitude of the acceleration. To find it, we must look at the FBD of block m. Knowing that there is a net force on m, we must realize that the net force is in the y direction. This must mean that mg minus t is equal to ma. For the two blocks on the plane, Ft minus F2 is equal to m1 plus m2 times a. Now we have to eliminate t to get a. So to eliminate t, we have to add both equations, and we get mg minus ff2 is equal to m plus m1 plus m2 times a. And we get that a is equal to mg minus ff2, which in this case is mu k2 times m1 plus m2a, as we did in the previous problems. Over m plus m1 plus m2. Thanks for watching.